Okay, hi everyone. Hello everyone. A nice sunny day, which is unusual. It's nice to find out about something, not about the service mesh, but we'll pick about networks and the vulnerabilities that we'll have to face covering the networks. Everything which is happening in the cube and in the infrastructure will seem to be like magic. A few words about myself. It's my handle everywhere in all of the networks, in all of the social media. If you have any question that you would like to ask, please write me and I'll try to find an answer. But please don't spam. I'm a tech lead for the infrastructure management inside the security team. We actually do it with the very critical cybersecurity products, and we try to provide cybersecurity solutions as a key. Corporate VPN and corporate PAM to get access to VMs and Kubes clusters. Some people say that I used to be a DevOps, but there are no ex-DevOps. You can do anything about the skills you have. I used to be a CTF player, but I'm not only a CTF player, but I also arrange CTF with my comrades. Seems like it works well for me. I also teach in the Voronezh State University, and I read some lectures in Moscow State Technical University, etc. So if you're somehow connected with these universities, you can find me there. But just don't interfere with the exams. So what we're going to talk about? We're going to talk about networks, Kubernetes routing and service mesh concept. We'll talk about a very interesting component called Istio. This is a very greedy and hungry component, and not everyone dares to use it. But if you have ever tried, you know what a magic thing this is. It allows you to do quite a lot of interesting things, and we'll try to break some cube clusters. So we'll take a look at some unusual cases that can actually arise when you don't know about something and when you're not thought about making your configuration right. I'm not going to speak about details in the mesh service, but let's think about how to bypass it and how you can protect from it. The first part with some interesting theory. What is service mesh? If you skipped those lectures in the university, don't be afraid, we'll catch up. A cube is just 5 binaries. That's what people say, 5 binaries per go. But if we take a deeper look at them, well, we're not going to drill down into specifics of how it works. The network which is interesting for us is Kube proxy. That's the only element which works there, and it's installed upon all of the modes. Not all of the DevOps know why they need that, because if this manifest goes to Kube, it works great. But if we say a few words about why we need this, at Kube proxy level, we answer this very simple question about the transfer of the cluster IP service into a specific group of codes. Like, for instance, this is one of the major cases that a proxy addresses. We have 3 types of services like cluster IP, at port and load balancer. With cluster IB, Kube proxy plays the role of a donator that donates to the right node by replacing the destination and returns the reply to us. There's nothing complicated. With the node port, Kube proxy works as a NAD, and it takes an inquiry from any node of our cluster, and it sends an inquiry to a new interesting pod. Where does this get this information from about which node is each pod? They don't know. It's the control plane that is responsible for that, and it reports to the Kube proxy where they need to route our traffic. And the load balancer, architecture-wise, it's the same load port, and it's only different with the external loader in presence, sometimes in the cloud, which will provide you the public IP address, and it will get you to the node port. And then everything works by the principles that we set in the node port. Without kube proxy, there are schemes, and Calico eBPF is based on them, Calico eBPF. Cilium is used in the eBPF cases, but today we will not get into detail about those things. They are interesting, but it's best not to do it today. I would only say that it works much faster because all of our nets is calculated at the core level, not in the user space. And CNI, Container Network Interface. It contains the interface of all of the containers. It's uniform. It's got interface standardization and plugins that allow us to implement different templates. There are two types of CNI: Flannel, Calico, and Cilium. Today we will speak about Flannel and Calico. We will not speak about Cilium because of the PF it has. But if you think that Flannel is outdated, I should say yes, it's outdated, but we can see it very frequently. Even now in 2024, there are plenty of clusters where Flannel is actually used and maybe used for some attacks. Flannel, and please apologize me, those people who have it, it's not a great solution in the contemporary configuration because it works as a bridge on the node. We have pods, we have the main network namespace nodes, we have pods. Each of them has their own unique namespace, and each of them has a virtual usernet interface which connects to the bridge in the root network namespace, and through this bridge all of the conversation occurs. If pods would like to enter big net and interact with other nodes with the use of the VXLAN overlaying network is arranged. L2 encapsulation helps us with that, and it's used as a transport there. As for Calico, Calico is a much better thing. Calico is made up of three nodes, three components, I would say, and for routing purposes, it will use PGP mechanism, Calico node and the Calico CNI and Calico Cube controller. CNI is responsible for realization of EPAM, management of IP addresses, and is responsible for providing for CNI rules. What it's so specific about Calico node? For those of you who didn't know, we have our nodes with the Calico node installed at each of them. The Calico Felix component is responsible for IP tables on the node and for filling out the internal routing table. And we use the Bird open source where all of the routes are spread across the neighbors. Everything works quite simply. So if everything goes well with the addresses and the nodes are close by, we would not use any mechanism here, but if our subnetworks are in crossover, we can use solutions to resolve this particular problem. But if everything goes well, if we don't need to combine a few nets together, it's best to turn off such tunnels. CompD component is responsible for the configuration of all of the Calico nodes. In actual fact, the Kubernetes is not responsible for traffic routing. We need a CNI for that. So if someone installed Kubernetes, you know that it's true. Now we are starting a more interesting part. Please raise your hands. who's worked with service mesh? I see, there are such people here. So obviously, if you've tried the box solutions like OpenShift, Istio is embedded and Red Hat supports this actively, but it's not a mass scale technology just because it adds X2 more resources on the node requirements. But it addresses a few interesting situations. For example, if you take a look at the following situation, we have service one. It has some kind of authentication. Let's think about how service mesh works. We have our service with authentication. We have another service which is twice as much as the first one. We have a third one which exists in two options, version 1, version 2, and the tests are run, and we need to have a deployment, so we send some part of the traffic to get the feedback, and very often we often have a fourth server with 3 replicas. One of them just jams, another one does not respond on time, and service 2 does all of the requests, and service 1 already addresses the canary, and we know that between S2 and S1 there's a very unstable connection, and not all of the requests reach their destinations. Unfortunately, it's our reality, and we cannot fix it instantly, but Istio and service mesh can ease the pain. Like the problems of service discovery may be addressed, the L4 and L7 load balancing, timeout, retry, and back-off policies can also, related problems can be resolved by Istio. And a nice thing like a circuit breaker should be mentioned here. If you ever seen a situation that some kind of a service with the load starts getting jammed, you wouldn't want to balance it manually and take it off balance, but to provide for automatic functions, and Istio is capable of doing it, of putting it off load, making it breathe, and then when everything normalizes, put it back in the system so that it makes our admins sleep well at night. And MTLS implementation. MTLS is not difficult apart from its management. When you don't have just 10 certificates, but more, you would want to rotate the certificates, watch for the expiry date, and make sure that it does not involve too many people. So obviously, service mesh creates their own security and policy rules, which gives much more flexibility than the classic network policies provided by Kubernetes, like off-LANL. What does how is service mesh structure implemented with Istio? If we take a look at the traffic in service mesh, we have a pod with the entire namespace with all of the containers launched, and we see that the traffic reaches the virtual interface. It leaves the virtual interface to CNI. We don't get into detail. It's a transfer which allows to interact with different pods. How do we control the traffic? We do it the following way. We add a special sidecar, a proxy into each pod, which completely intercepts all of the traffic. So all of the inbound and outbound traffic to the container goes to the sidecar, and the sidecar proxy can basically be any load balancer, but in Istio it's Envoy. For configuration of all of these proxies, you have a control plane that can be configured. Now let's take a look at how it works in Istio. In Istio, we have the control plane and our sidecars. The sidecars are envoys, and the control plane that we see here, and if we see what the sidecar does, we donate each traffic with DNAT, each one to the ports. So what are the components for the Istio? They are made up of pilot components. It's a pilot component. It's not the pilot that puts the settings, but it's the envoys that take the settings from the pilot. It's the mixer component. It's a mixer component for different group policies, for cluster policies, for envoys, which is capable of loading telemetry to the external systems and Elastic, for instance. And this is the MTLS component, the Citadel, which allows us to write out the keys and arrange the MTLS with a few strings of config. So, a quick summary. Istio is the interface to manage dozens of envoys. It's a great interface which automates the configuration in the groups. The pilot configures envoys, mixer sets the policies, telemetry, and CTDL operates with the entire life cycle of the certificates in the cluster. So I think it's time for us to address something interesting, show the examples of vulnerabilities. Now, with more theory that we are backed up with, we'll learn how it works. Let's try and think where we can hit. You can hit to CNI misconfiguration. It really all depends on how the person provided for proper secure policies, and they have prohibited certain ways, or everything is allowed. Maybe we'll try and go and steal some certificates for MTLS. Istio is very sensible to that, sensitive to that. I mean, if you steal a route certificate and the private key, then MTLS certificates issue will no longer be a difficult task, a challenging task. Istio misconfiguration, and like we said, Istio is the control panel for envoys. It does not look that bad, but we try to get into envoy CVEs, and we'll see a lot of funny things to deal with, because envoys work like this. They have a lot of CVEs, and you can bypass different headers and get authorization. And with Envoy, approximately a couple of packs of such things are generated each year. Okay, let's take a look at CNI misconfig, fake IPv6. Okay, but we don't use IPv6 in the clusters, it's IPv4. That's true, that's right. However, IPv6 is actually permitted. It was fixed at the version 0.25 and further on, but previously that backdoor existed. You need to have the plugged-on plugins. So by default, even if you have Istio there, if you don't have Istio there, it doesn't really matter. So by default, you will have IPv6 addresses working. What's the point? It's working not in the way the IPv4 works, although the targets are the same. So, for example, we have packages in the CNI, so we add IPv6. What happens here? Imagine that our DevOps or the security engineer sets the policy which prohibits interaction between the two pods, S1 and S2 pods. However, with the use of the IPv6, they can connect with one another. How come? Because IPv6 has router advertisement, an invitation which is sent through a multicast saying, I'm a router. I'm a router, please connect. Please connect. And in this particular mode, we can send ICMP v6 messages, which is an advertisement to the neighbors, and they start considering us a router without any inspection and checkup running. In this case, we will get all of the traffic through us. If the traffic is encrypted in the clusters, we won't be able to do anything. But not everyone tunes the encrypted traffic options, because sometimes it's quite difficult to do just operation-wise. So we can intercept those inquiries and establish a CDNS service. So we send an invitation, and that's it. Pod 2 considers us a router. Voila! And the exploit looks like this. It's a pod which is configured with the operating system, like Debian, for instance, I think. So we can send this string with a fake router advertisement, and this is it. Our victim will think that the example com returns this reply, because we just returned this to them. So how do we fix it? First of all, you need to run an update. Number two, if you don't need IPv6, you just shut down IPv6 routing. If you have Istio, you just need to shut down the IPv6 support on Istio. And do the same here. This will prohibit router advertisements. Another thing, ARP spoof. I'm not going to speak about the ARP protocol, but if you remember, this is the transformation of IP addresses to MAC addresses. That's the transition level between 2 and 3, because at level 2 we only have MAC addresses and no IP addresses. Where will it work? We remember this flannel story with the bridge. So things, we think everything connects to the one bridge. If we take an IP, kubedns, if we take all of the MACs of the subnet with the multicast, if we take MAC and the IP host on the bridge, and we start sending poisoned packages to Bro, we will send a lot of ARP packets which will say that the IP, when addressing pod A and pod B, can subdue the messages saying that we are pod B, and pod A will believe it, because we will be generating just simply more messages, and the networking equipment can cope with that. But if you have a flannel, you're exposed. You can assemble a cluster and check this out for yourself. Number 3, Calico set UID. Calico does not have too many vulnerabilities like Selenium, but with the Selenium there's a big community, and whatever, think for yourself. But Calico on average may have one CPU per year and CVE per year, and this is the last CVE which allows us to do so. If you're in the node and if you are not root, it's a rare case scenario. If you somehow breached the node, you are most likely being rooted, you have the root rights. It allows you to run binaries on the root level. How does it work? Calico creates a directory if it's not there and is installing the suite bit, so it starts it from root. So the directory has the root access, and in the bin folder all the binaries are run with the root rights. So if we can write additionally some Calico binary with the CNR binary false flag, you'll be able to launch your own fake binary instead of official Calico binary, and what you will include into that binary, it's up to you to decide. Istio bypass. Now we think we won't be able to bypass Istio, but what if we have a third-party container which intercepts our traffic? What are we going to do about that? The policies will not allow us to do so. Yet, if we have two containers in the Docker that are in different namespaces, and two containers in pod are two different things, because we have common namespace and the common namespace for the users. If you somehow receive the root rights in the main container, you get the root rights in the Istio container. Istio works from UID 1337. If you put this, you'll get access to IP tables, and this is it. You're beyond Istio jurisdiction. You're beyond this jurisdiction and outside the system. It's a small number of vulnerabilities I enlisted and showed you, but they are funny ones that were tested. And I think what we've heard here today was useful for you as general knowledge, and you just had some fun taking a look at different network vulnerabilities. Please vote for my presentation and send more questions. Thanks a lot, everyone. Well, thank you for your presentation. It was very interesting. I will ask this first question. I'm an admin. I'm in for speed. How many milliseconds does Istio add? Actually, it's X2 utilization. Well, it's rough. It's rough. Don't install it. We have a question from the bot. Isn't Istio getting old? Cilium covers more of the tasks. Yes, I agree with that. Cilium is faster. It covers more tasks. But approximately a year ago, there were funny problems with putting Cilium on Russian-made operating systems. eBPF would not work there. And they use Calico there instead. And what about Istio being old? Istio is a good service mesh which is developed by giants, and it's got its niche. Big banks, for example, banking services, those people who can afford more hardware solutions, but they can make their development cheaper. When the developers work with this simple code, it makes it cheaper. What about the situation with the Russian operating systems? Anything changed? I didn't track it. The last thing I remember was 1 year ago. I don't know. Two questions from one person. What do you think? Will the situation change when we move to Istio 1.273 with a fully fledged stack solution? Yes, I think it will change. Istio is moving away from an obsolete sidecar solution, which is becoming more contemporary service mesh with a higher performance. The question is when the main user will migrate to it. What's the problem with migration? The problem with migration is more about organization. The next question, did you ever compare how much the Citadel performance reduce? Have you tried Ngress and Nginx? Nvoice and Nginx, I didn't compare them.
В моем возрасте неправильно говорить слово старой закалки.
I wouldn't say that I'm too old. No, not. Nginx, I like it more. So when we need to configure manually, I use Nginx. But when Envoy is applied, I don't really like the configuration policies by Envoy. With Istio, we had to establish filters. I was suffering, but I was writing a lot with Envoy. I don't do it anymore, and actually I like it. Do you have any questions from the floor? You may ask any question you like. Get the microphone here.
Да, спасибо за доклад еще разок.
Thank you once again. One of the vulnerabilities you described is set UID for one of the binaries.
При подмене-то там ситуация
If we replace
идет на ноде вообще.
the binaries, will there be a DOS problem on the node? Or you just need to do it quickly with the reverse shell? No, it's already uploaded into the process. There will be no DOS.
Друзья, еще вопросы. Напомню, у нас есть призы за вопросы. Их будет
Thank you. Do you have any questions?
организаторов конференции.
By the way, you will get awards
Поэтому
from
не стесняйтесь, поднимайте руки.
the organizers of this show and a separate prize from the Wildberries company. Let's give the microphone to this gentleman.
Спасибо за доклад, классный. Ну,
Thank you very much for your presentation. I don't see much information about Istio. So there was an example with the Istio vulnerability shown. So maybe you know about that they used 1337 UID so that the Istio policies do not work for you. Do you have any policies to check that the user is not launched? Do you have any policies? Do you have any policies where you can monitor that the process is complete with the user 337? If I understand it correctly, if there are any policies that cannot be cancelled by the user, can we detect it? There are nice things like Kube, Istio, they're all working on standard Linux stack and things like that. So officially a lot of things changed, but not too many. So first of all, the Kube has got a very nice function like service accounts with lots of exploits, scenarios maybe introduced there when you get the service account with the rights. And however wide the policy is, if you have the right to it, you will cancel that if you play it by books. If you don't play it by books, you just get to the protocol level and you see the wrong configuration, the misconfiguration examples. Like with Istio, nobody has ever thought that you will cancel that. Nobody is protected from that. But you've never seen this example, like the people saw 1337 process and the container would be eliminated. Not because the 1337 is a standard UID Istio, and through this UID, Istio works. The Istio LCAR is not just envoy, but Istio sidecar takes the settings from the pilot and configures Istio by a network interface. It can apply the settings on the fly and they configure it, but it requires some help. And this is when it initializes and it reconfigures envoy, it works with 1337. If we don't put these settings right, by default, even if you change it, nothing will ever work and the magic will be over. Thank you.
Как бороться с RP-спуфингом?
How do we eradicate RP spoofing? Not to use Flannel.
Можно попробовать.
Well, you can give it a try, of course. If I remember correctly,
Вот как программно сделать? Да просто бриджи не использовать, либо...
you don't use bridges, so control this muck flooding and cut this traffic out. Can you use MPS in the local network of the company, MPLS in the local network?
Смотря для чего вы его используете.
Well, it depends on what you use MPLS for. If you come up with L2 VPN, that's justifiable.
Есть возможность.
If you have a capability of doing this, but that's an external network. Well, it really all depends what you're going to use this for. Okay, I understand. Next question. To implement the first two attacks, you need to have the root rights. So the control over the rights mitigates these attacks risks. Yes, almost exactly, but very seldom one real comprehensive attack will be just from one CVE. It's because of the a set of vulnerabilities because something was badly misconfigured. We have the practice of mis-TLS, where you won't get the root easily. And if we drift away from the root concept, and if you get to the root as demons, that's right. That's where it's not going to work. But if everyone followed these rules, I think it would make the world a better place. A comment here from you. You decided to skip Cilium. It's from version 13. It supports MTLS data path, and it does away with the Istio. Have you tried that? No, I just speak about what I put my hands on, and my hands did not reach that service mesh. I think I should give it a try. Please find it in the next presentation of mine next year. Okay, we'll wait for you here. And the final question. Can you come up with a case the flag in Kuber? Was it safe? I actually know who asked this question. It's Yaroslav Guzenko. Yes, thank you, Yaroslav. I think you were there as well.
Ну, а что нет?
So why not? Because, you know, we all have sins. We indeed were hacked. Those were our mistakes, and we learn from mistakes sometimes. Thank you very much. Do you have any other questions? Oh, yes, one more question here. What features do you use, and what profit did business get from getting this implemented in numbers? When I was working with Istio, I did not have such privileges to implement service mesh. We inherited that from Red Hat subscription. It was supported just because it was just one single solution. And about profit, I think in terms of the business application, Istio allowed us to do the following. They can write the business code without actually thinking much about anything. All of the microservice patterns can be implemented there. But I would say it's very difficult to configure complicated things that are not described at Haber website. You just need to get into envoys. You just need to look for Istio API. And as a DevOps, I hated that. But as a security guy, well, where it was implemented, I don't remember any big-scale cyber attacks at all. But they were possible, but I think there were chances there. So there were 0 big-scale attacks. We have a question from the floor. Excellent presentation. Thank you very much. Those network attacks are classic. RP spoofing, IPv6 based ones. But on the other hand, if I remember that right Calico works BGP via Bird. What about BGP specific attacks in service mesh? Have you seen them? When I was preparing this presentation, I thought about looking up such information. I personally did not meet them. I can't answer this question of yours. I need to read and learn about it. BGP. I think you'll be able to find quite a lot of interesting information. That's for sure. You just need to check up